Hi, everybody. So for our very first lecture, we're looking at chapter 1, psychology as a way of thinking. So looking a little bit at how do we define psychology, what is empiricism, the theory data cycle, different types of research such as applied, translational, and basic research, and then a little bit about the publication process. And just a quick reminder with these lectures, this is my attempt at covering some of the materials that are in the textbook. So not a bad idea to maybe consider taking notes, or you can just know that these are here for you if you'd like to watch them again. But the materials here will definitely be related to those on the exam. And it's my way of trying to kind of connect with you in a more traditional lecture format. So I'm lecturing with these slides, but again, you might consider taking notes, or you can just watch this again if you feel like you would like to. So as we jump into chapter 1, and this is kind of a brief chapter, it's setting the stage a little bit for what we'll think about all semester. Psychology is the scientific study of mental processes and behavior. And so right off the bat, psychology is a science, right? A scientific study of mental processes, all of our senses, our thoughts, and our feelings, along with our behavior, right? Everything that we do. And the key, again, is that psychology is a science dating way back to the days of Wilhelm Wundt and his work in turning psychology into more of a scientific study rather than being more philosophical. But psychology relies on empiricism rather than intuition. It's a very empirical study, right? Using evidence from our senses or from instruments that assist the senses as a way to draw conclusions, as a basis for our conclusions. So rather than using things that are a little bit more subjective or intuition based, we're trying to use things that are more objective and a little bit more empirical. So when we talk about people relying on intuition, we're talking about common sense, gut feelings, things that are very subjective and maybe unique to an individual, versus empiricism is something that's a little more objective and hopefully using a little bit more evidence. And that is something that is definitely very characteristic of scientific studies. Now, another thing that the book goes into is that research can have both producers and consumers. And you can be both, of course, but producers are people who create new research, right? They're out there conducting research, producing new studies, versus consumers are people who are maybe, digesting things, they're reading things, and they're consuming it in some way, maybe as a part of a journal article or a book, and so on. And something that is really, really important, I think, and probably one of the most key takeaways from this chapter is learning to become a critical or smart consumer of information. Right? And this is something that is kind of a big concept in the idea of science versus pseudoscience and intuition. Is regardless of the career that you choose, you want to be someone who can read research with curiosity, with the aim of understanding it, learning from it. You ask appropriate questions. You have a critical eye, and you interrogate the information that you receive. You don't just accept things blindly. You want to ask questions about it. Who conducted the study? Do they have an agenda? Is there anything that they have to gain from this? Do they have the expertise to back up the claims that they're making? A large proportion of studies are not performed accurately. So it's really important to learn how to distinguish the good from the bad studies, right? And knowledge about research methods helps quite a bit with that. So as we go through this course over the semester, hopefully you'll learn little things to look for. You'll learn how to spot some fake news. And there's an incredible amount of fake news. And I talked about this a little in the lecture on Canvas, that many of the studies that are done show that people can be so easily misled, especially those who are younger, maybe in elementary, middle, high school, and so on. But when you are looking at anything in the news, you always want to consider the source. Check the author, check the date, right? You want to see, when was it published? Is it still current and relevant? Check your personal biases. Ask the experts. Is this something that is more of a joke or more like clickbait and just kind of pop culture? Or is it more scientific? What are their supporting sources? You want to read beyond the headline. Headlines, as it says on this page here, can be outrageous in an effort to get people to click on things. I fall victim to this all the time, right? There'll be a story, it'll say, you'll never guess what so-and-so said about so-and-so, right? Related to football, oftentimes for me. And I have to click on it because I have to know, right? You always want to read beyond the headline, consider the source, and find ways to be that critical or smart consumer of information. Now, when scientists are conducting research, they use something called the theory data cycle. You've probably seen this before. It very much connects to the scientific method and this very circular approach to testing hypotheses and generating theories and kind of going through this whole data cycle. A theory is something that's going to describe general principles about how variables relate to one another. In other words, it's an explanation trying to describe how things are connected. And theories can lead us to all sorts of kinds of research questions, which can then lead to a hypothesis. A hypothesis is a prediction about the outcome of research that is based on a theory. So you come up with a theory, or somebody comes up with a theory that makes us have some questions. Then we come up with an idea of how maybe can we conduct some research to answer those questions. What are our hypotheses? What are our predictions about the outcomes of the research? And then we go out and we collect data in order to get at that information. It either supports it and strengthens the theory, or maybe it doesn't support it and we have to go back and revise our theory or improve the research design, things that we'll talk about over the course of the semester. But data is simply, right, a set of observations. So it's this round and round we go approach of theories leading to hypotheses, leading to data, and then we either have to revise our theory or we find support and confirmation of it. When it comes to good scientific theories, right, what makes a theory good? What makes something good in terms of, we're talking here about like psychometrics and sound methodological approaches. Good scientific theories are supported by data, right? Supported by information that we have gathered, as we just talked about on the last slide. Good scientific theories are also reproducible, right? There's something that you could do again, and we'll talk about replication studies later in the semester, but there's a variety of evidence and data that support the theory. Good theories are also falsifiable. A theory must lead to a hypothesis that when tested could fail to support the theory. Now, we have to phrase this in the right way, right? So for example, we could say that the Loch Ness contains a giant reptile. Can I show that to be false? That would be very difficult to do versus what if I make the theory or the hypothesis that only blue cars exist? Can I show that to be false? Right? If I only observe blue cars, if I only see blue cars everywhere, does that prove my hypothesis to be correct? I can falsify it the second that I see a car that's a different color. Mine is gray, so right there, I can show that to be false, right? So I can falsify that information. It's very difficult to prove something to be correct, much easier to falsify a hypothesis, and that tends to be the route that we go when we're looking at good scientific theories. We can't necessarily prove anything. Any headline that tells you something is proven is probably going to be a little bit misleading. All we can do is evaluate theories on the weight of the evidence that we have. The data either support or are consistent with the theory. It's very difficult, if not impossible, to prove something beyond a shadow of a doubt to be true. We also want something to have parsimony. Good scientific theories, with all other things being equal, in general, the simplest solution is often the best. So we want to try and keep things simple. We're looking at, can we falsify a hypothesis or an idea that we have? We want supported data that's reproducible, and we want things to be empirical, right? Based on data and based on evidence. When scientists are tackling the problems that we have, and psychologists, again, are scientists, we can kind of divide this up into three different basic we could say approaches here: basic research, translational research, and applied research. Basic research, the goal is to enhance the general body of knowledge about a particular topic. So if we look at this example right here, what parts of the brain are active when experienced mediators are mediating or meditating. Meditators are meditating. So when somebody is meditating, what parts of the brain are active, right? And so what we could do is conduct in here, like they're doing an EEG, to look at what parts of the brain are being active when somebody is meditating, not mediating, but meditating, right? First lecture of the semester, right? Translational research is a bridge from basic to applied research, in which the findings from the basic research that we've conducted are then used to develop some kind of application. So for example here, right, in a laboratory study, can meditation lessons improve college students' GRE scores, right? So here now we're taking something related to meditation and looking at, can we maybe use that as something that could connect to GRE scores? It's a bridge between the basic and the applied. Applied research is conducted in order to solve a practical problem, right? So has our school's new meditation program helped students to focus longer on their math lessons? Is this specific practical thing that we are doing, is the application working? Is it helping students to focus longer on their math lessons? One last concept here, oops, sorry, I hit the wrong button. One last concept chapter, again, kind of a shorter chapter setting the stage, is scientists tend to make their findings public, right? They go through an intense publication process. They share the results with the scientific community, typically through submitting to a scientific journal, right? So when people conduct research, they conduct scientific empirical research, it tends to go through this science news cycle, right? Where they conduct the research and then it is peer reviewed by other people. It's submitted to a scientific journal where a panel of experts will often read it to make sure that it is sound and correct and should be published. It is quite a process, right? So something that we'll talk about more throughout the semester. When somebody does conduct research, it's typically published in the scientific community in the form of a scientific journal or a journal article that we can all then read, which could lead to more research and more publications and kind of going through that entire cycle. So again, mostly setting the stage here, and what you'll see in these lectures is I'm not always going to cover everything in the chapter, but I will cover some of the kind of key concepts to help you out. So thank you for watching our very first lecture here. What you're going to want to do now is to go and get going on all the other required materials for this week. And I will see you all for our next lecture and our next topic next week.